Hello everyone, welcome to my channel, and in today's lecture we'll be continuing with amines, that is preparation of amines. In the previous video I have discussed few methods of the preparation of amines, so we will be continuing with the next method, that is Gabriel Phthalimide synthesis. Now where do we use this method? This is mainly used to prepare 1 degree amines, primary amines. Okay, and how do you identify primary amine? NH2 group. And what type of primary amines can be prepared by this method? You can only prepare aliphatic amines. Okay, there is one recent question asked that aromatic amines cannot be prepared by this method. Aromatic amines cannot be prepared. They cannot be prepared by Gabriel Phthalimide synthesis. It's a recent question asked. Why we are not able to prepare, we will be discussing when we are talking about the reaction, then it will be clear. Okay, so first what we do is, you can note down this question till then. Primary aromatic amines cannot be prepared by this method. Why? So what we do is, we take here phthalimide. Now what is phthalimide? This is phthalimide. Okay, so this is first treated with alkali, that is KOH. Okay, so what will this do? This will come out, H and OH will come out as water. Okay, so water will come out of this. I will be explaining the mechanism separately for better understanding, but first I am just telling you how to write down this equation. Water you remove, so rest everything will be fine. This K will be attached to N. So what happens is, this is CO, this is CO, and you have here N, and this is K obtained. Of course, this is more electronegative and this is comparatively electropositive. So this will get positive, this will get negative charge. Now there is a reaction with alkyl halide, that is RX. So what will this RX do? Obviously this is more negative, this is negative, this is positive. So what will happen is, this K and X will come out, right? So this will come out as KX. You will remove this KX, and then you will have this getting attached, R getting attached over here. So what you will have is this ring CO, this is CO, you will have here N, and you will get R attached. Now what is this called? This is called as N alkyl. On N there is alkyl group, so it is N alkyl phthalimide. pH is silent, phthalimide. Okay, N-alkyl phthalimide. Now this last step, whatever you get here, is to be hydrolyzed. It's to be hydrolyzed with either NaOH you can write, or you may also write KOH. Okay, so using the base you have to hydrolyze it. When you hydrolyze it, just for writing, how will you remember? Right? So you will remember like this. You will break it from here. You will break it from here. You will write down NaOH twice. NaOH here. You will write here NaOH here. This is for writing in the board exam if this is asked. So what is left over now? This part is RNH2. That is one product which you are getting. Apart from that, you are getting this ring, the phthalimide product. So what you are getting here is, this is C. You will have here CO and ONA. Or OK also, in case you are taking potassium. This is CONA. That means you got a sodium salt of this phthalimide. One. And the second thing what you are getting is RNH2. That means primary amine is obtained. You are getting primary amine. This is the reaction you have to write down for Gabriel Phthalimide. Okay, now let me give the answer to the question which I asked you, but before that I think I'll explain the mechanism. Now I've written the steps just to save time to explain the mechanism. This is the mechanism. Okay, so what exactly happens in this? This is phthalimide. Phthalimide you are treating with the base that happened in the first step which we have done. This is more electronegative, nitrogen. So it will pull the electrons towards itself. So when this pulls electron toward itself, this bond will go towards N. It will become N minus, and this H plus will come out. So that is a proton. In a way, this is acting as an acid, and this is a base. It's giving OH. So this OH and this H, which is given by phthalimide, it comes out as water. Right? So this N was minus, so this N minus and K plus will together, now K plus will form a bond with this N. You get the potassium, so potassium getting attached to nitrogen. Okay. So then what happens is, the product which is obtained here is now again made to react with alkyl halide, where halogen being more electronegative pulls electrons toward itself. Halogen gets partial negative and the alkyl part gets partial positive charge. And same way here, the N was having negative, so that negative gets attached to R. So it gets attached to R, so you got this, which we earlier wrote it as N-alkyl phthalimide. This was fine till here. Now, in this particular step, there is no H plus, so it is not acting as an acid. In fact, this part is providing that minus. So this is acting as a nucleophile. It is acting as a nucleophile. The phthalimide ion is acting as a nucleophile, and this nucleophile is attacking Rx. Had this been aryl halide, which we said no, it will not undergo, it will not prepare aromatic amine. Suppose this was, instead of R, it was aryl halide. Then, you know, in aryl halide, there is a double bond here. Because of resonance, partial double bond character is there. So due to the partial double bond character, this bond will not break. So aromatic amines, aryl halides cannot undergo nucleophilic substitution reactions easily. That we have already discussed in haloarenes and haloalkanes. Okay, so what answer you will write down for this particular question? Aromatic amines cannot be prepared by this, because if we have to prepare aromatic amines, we will have to use here aryl halide, and aryl halides cannot undergo nucleophilic substitution reactions easily. In this particular ion was acting as a nucleophile and was attacking the alkyl halide, so which it cannot do for aryl halide. Now what happens is, you got this R at getting attached here, you got this. Now further we carry out the reaction with the base, that is KOH. Now in this case, it is not acting as a base. KOH is not acting as a base because there is no H plus here, there is no acidic hydrogen here. So in this case, this OH minus is acting as a nucleophile. It is acting as a nucleophile and will try to search for some positive charge. So you know, this is more electronegative. It will pull electrons toward itself. As a result, the carbon will get a positive charge. So this OH minus will attack the carbon. So when this OH minus attacks, what happens? It forms COOH. When this gets attached over here, what happens is this, this is I have written here. Okay, so further one more step I have included here just to, because of the shortage of the space. What happens when this comes here? This was negative, carbon was positive, so OH got attached to this carbon. And due to back bonding, the lone pair of the electron from here again goes back, makes this as a double bond. When this makes it a double bond, the bond between carbon nitrogen will break, because this is more electronegative, will pull electrons toward itself and will break this particular bond between carbon nitrogen. So when it breaks that bond, what will happen? It has formed now C double bond OH, and this electron has gone to N, which I have shown in the next step. Fine, the nucleophile attacked the carbon. And why it attacked? Because due to this going here, it became negative, carbon was positive, and again due to back bonding, this becomes a double bond. And when this becomes a double bond, the carbon valency is disturbed, so this bond moves towards nitrogen. So what you get is this species. Right? Now further what happens in this is, there is proton transfer taking place. There is proton transfer. How proton transfer? This was negative. So what happens is, from here, this H plus, How this is H plus? Because this is more electronegative, it will pull electrons toward itself. So H plus will go and attack this nitrogen. So this nitrogen, when it is attacking, you get this. Okay, and there was K plus also. This K plus will get attached to this O, because when this bonds goes over here, this oxygen becomes negative. So this negative and K plus will form this. So what changes? That K plus I have written here, from here H plus I have taken there. One more molecule of KOH. Instead of KOH, you can use NaOH also. One more molecule of KOH will attack. Again, this OH minus is acting as a nucleophile. So what it does, it will attack the carbon atom, because this pi bond, same way as I did here. Okay, this will go here and this becomes positive, this becomes negative. When this becomes positive, OH will attack here. And due to back bonding, this again comes back, and again the bond between carbon nitrogen will break. So when carbon nitrogen bond breaks here, what you will get? RNH, and because this has gone here, it becomes minus. And this OH I have attacked here, so this was the species which you are getting. Right? Now the last step is left over, that is proton transfer. Because this is negative, this H plus will lose there, this will go towards O, H plus will come out, get attached here, you will get the final product as primary amine. This was minus, so the K plus now will attack there, and the final product which you will be getting here along with that is COOK here and COOK. That is the potassium salt of the phthalic acid will be obtained. Okay, just note down the mechanism and just see whether you have understood or not. As far as board exam is considered, no need for the mechanism. But in this mechanism, actually, you are able to understand in the first step, this was acting as the acid, this was acting as a base. Here, this is acting as a nucleophile. Aromatic amine, that is why cannot be prepared. Then I told you here, this twice that KOH was added. This KOH was acting as a nucleophile, not as a base like in the first step. Okay, now one more method is left in the preparation that we are going to discuss, that is Hoffman's bromamide degradation reaction. Okay, so let's discuss this. What happens in this Hoffman's bromamide degradation reaction? It is, you are taking amide, say RCONH2. Okay, this you are making it react with bromine, and then in the presence of the base the reaction occurs. And what you get is 1 carbon less you get in the product. So that means what you are getting is RNH2 plus what else will be there? That means this is going to be removed. So how will you remember the product? One product will be Na with Br, another product will be Na with this carbon. It will form a carbonate salt plus water. So you will write down the products as NaBr plus Na2CO3 plus water. So, and if you want to balance this equation, it will be 4 NaOH over here, it will be 2 NaBr and 2 water molecule. Okay, so basically what happens in this reaction is there is a migration of the alkyl group. Instead of alkyl group, you can use aryl group also. I will write down and show it to you. There is a migration of the alkyl or the aryl group from the carbonyl carbon. From here it will go and get attached to nitrogen, because this part gets eliminated in the carbonate salt. Now suppose I am using here say CH3CONH2 and I am using the similar reagents, bromine plus NaOH or KOH, whatever. So what you will get is 1 carbon less amine you will be getting, plus all this stuff will be common. Okay, this will be there, right? Now in case I am using some aromatic thing, that means suppose I am using here benzamide. Okay, suppose I am using this. Okay, then react this with bromine in the presence of NaOH. Okay, so I think you can write down the product here, what you'll be getting. 1 carbon less, that means this will go away. So you will get the product here as this and NH2. Okay, that means aniline will be obtained. Apart from this major product, you will have the other products also, the common one, that NaBr or carbonate and water. So this is a very, very important reaction in case you are aiming for step down. Step down means one carbon, if we have to reduce it, then you can use this reaction. I hope it is clear. Now with this we have completed all the preparation methods. Please practice these preparation methods properly, and in the upcoming videos I will be talking about their physical and the chemical properties. So stay connected, stay updated. Thank you.